with 43,000 pounds of thrust propelling it to over 1.5 times the speed of sound. The F-35 Lightning II holds a verified kill ratio of greater than 20-to-1 against advanced threats. This level of performance begins in a mile-long factory in Fort Worth, Texas. Lockheed Martin's Plant 4 has produced military aircraft since 1942, starting with the mass production of B-24 Liberator bombers during World War II. The facility evolved over the following decades, manufacturing thousands of iconic legacy airframes, including the F-16. Today, over 16,000 employees work within these walls, pushing more than 100 new F-35s out of the hangar every year. Every one of those aircraft is engineered to execute air-to-air, air-to-ground, and carrier-based operations from a single multi-role platform. To see how that versatility is achieved, we are going to digitally deconstruct the F-35 layer by layer to uncover the engineering behind its dominance. Stripping away the skin reveals the foundational wing systems. The assembly line builds onto this skeleton in a modular process, adding components in a strictly defined sequence. Each station adds a specific subsystem, wiring, hydraulics, or structural supports, piecing the aircraft together toward the final rollout. Specialized robotic cells named Blue Delta, Echo, and Charlie handle the high-precision tasks that are too repetitive or chemically hazardous for human operators. These robots perform the fastener fill process, injecting plastic material over every rivet and joint. The robot then smooths the exterior to ensure the airframe remains invisible to radar. Because even a single exposed screw head could create a detectable radar return, the F-35 stealth profile relies entirely on this level of manufacturing precision. Moving inside the canopy reveals the pilot station. The interface consists of a side-mounted control stick, a throttle, and a series of glass digital displays that consolidate all flight systems. Operating this machine in a high-G environment is physically exhausting, requiring pilots to utilize specialized breathing techniques to remain conscious during aggressive maneuvers. This helmet acts as an integrated sensor for the pilot. The carbon fiber shell and reflective visor contain the electronics necessary to maintain constant situational awareness. The system projects a virtual head-up display directly onto the visor, placing targeting data and flight instrumentation exactly where the pilot is looking. By stitching together feeds from cameras located around the fuselage, the helmet allows the pilot to look down through the floor of the aircraft to see the environment below. This integration ensures the pilot is the most connected asset in the airspace, synthesizing thousands of data points into a single navigable field of vision. The B model variant features a unique engine nozzle that mechanically pivots 90 degrees downward to support short takeoffs and vertical landings. To maintain a stable hover, the aircraft divides its 40,000 pounds of thrust. Half is directed through the rear nozzle, while the other half is routed to the front lift fan. The F-35 utilizes two internal weapons bays to carry its primary ordnance, allowing it to strike targets while maintaining a clean, stealthy exterior profile. When stealth is not the primary requirement, the jet can be configured with heavy exterior payloads, including JDAMs and small-diameter bombs. Specialized underwing pylons can also be fitted to carry a range of air-to-air missiles, such as the AIM-9X. This modular arsenal ensures the aircraft can be tailored for any mission, transitioning from a hidden predator to a high-capacity strike platform as needed. Integrating these high-precision components into a single airframe results in the combat-ready F-35 Lightning II. These machines are now deployed on carrier flight decks and air bases across the world, operating at the leading edge of modern aviation. In flight, the aircraft's engine produces the raw power necessary to sustain speeds exceeding Mach 1.5. The result of this complex manufacturing process is a flawless aerodynamic predator, capable of executing high-G maneuvers that would tear lesser aircraft apart. The presence of an F-35 alters how adversaries plan and behave, forcing them to account for an aircraft they cannot reliably track or engage. By merging stealth manufacturing with unprecedented sensor integration, the F-35 stands as the most survivable and connected aircraft in the sky.